Hello students. After the completion of our nucleophilic substitutions reactions, as we know that in our nucleophilic substitutions reaction session, right? So various 4 or 5 sessions that we have to conduct. So in this session of nucleophilic substitutions reactions, firstly we focus on how many nucleophiles which can be added towards to the haloalkane as well as haloarene. Then after we studied about the mechanism of this SN1 and SN2 reactions. Then the third sessions which can be mainly focused on stereochemistry and optical isomerism. And then after our last sessions was associated with a mechanism of a SN1 and SN2 mechanism with the help of optically active haloalkanes. And some problems in text problem and the NCERT exercise problem that we have to solve it. So now today's lecture is based on a second reaction. It's called as an eliminations reaction. It's a eliminations. What is the meaning of eliminations reactions? Means we have to remove. So if we have to remove or eliminate, so regarding to the eliminations of the molecule, name of the or the specific name which in this case we have to discuss about the dehydrohalogenation. The meaning of dehydrohalogenations means we have to remove hydrogen and halogens simultaneously, so it's called as a dehydrohalogenation. If such a reactions will remove hydrogen, so it's called as a dehydrogenation. For example, if we remove carbon dioxide, so it's called as a decarboxylation. Same way, if we remove a halogen, then it's dehalogenation. So in this case we have to remove a hydrogen halide, so it's called as a dehydrohalogenation. This reaction is further known as beta eliminations reaction. So today in this full lecture we discuss or in a very deep manner what is eliminations reactions, how it will conduct, what is Satzef rule, what are the orientations of dehydrohalogenation, what is the ease of dehydrohalogenation, and most important reactions is the eliminations versus substitutions reaction. So first we starts with the eliminations reactions. So first example which can be given like that, this is CH3CH2Br. We know that the compound name is bromoethane or ethyl bromide. What is the prime condition for eliminations? Now, in the prime conditions of beta eliminations reactions, it means that you have a beta carbon in your molecule, and beta carbon having a hydrogen is your mandatory conditions for dehydrohalogenation. So what is alpha carbon? The halogen containing carbon is alpha, and the neighboring of alpha carbon is called as a beta carbon, and the joint group of hydrogen with beta carbon is called as a beta hydrogen. So when an haloalkane is heated, because here heat is required, because here in this case breaking of bond, two bond that we have to break as compared to the nucleophilic substitution 1 and 2. So it's require more amount of energy with a concentrated alcoholic KOH. With a concentrated alcoholic KOH solution, a molecule of hydrogen halide. So here from alpha position there is a removal of bromine, and from beta position there is a removal of hydrogen. So alkene is formed because there is an unsaturation between alpha and beta, so it's converted into alkene. So the hydrogen of alkyl halide which is eliminated from beta carbon and halogen from the alpha carbon. So since in this reaction, right, the hydrogen atom is lost from the beta carbon, therefore this reaction is classified as a beta elimination reaction, because in a very depth manner for advanced topics, so there are alpha eliminations, beta eliminations. Under the title of beta eliminations is also classified into E1 mechanism, E2 mechanism is the same that we have to study in SN1 and SN2 too. But today our lecture is mainly focused on your NCERT textbook and some depth that can be carried out in our lecture. Okay, what is the orientation of dehydrohalogenation? So if for example in this compound the halogen is present on the terminal carbon, okay, of the terminal carbon of the chain. So dehydrohalogenations occur only in one direction, because this is alpha and beta, so only one direction, because no other direction which can be possible in this compound. So the name of this compound is 1-chlorobutane, chlorobutane. When this 1-chlorobutane is react with alcoholic KOH, okay, so at that time the reactions which can be occur only in one direction, so gives one terminal alkene. For example, 1-chlorobutane, removal of chlorine from alpha, removal of hydrogen from beta, so it's a removal of hydrogen halide. So there is a unsaturation between alpha and beta, so it's converted into but1ene, it's a terminal alkene. We know that according to geometrical isomerism, this but1ene does not have any geometrical isomerism, so only one and one product which can be formed, okay. But if the halogen is present, on any carbon atom within the chain, so in this case the halogen is present on not a terminal position, but it's a second number carbon, right? Second number carbon. So the alkyl halide can undergo dehydrohalogenation in two or more different directions. Here in this case only two directions that we have to observe. So two or more different conditions depending upon the number of different types of beta hydrogens available. Here 3 beta hydrogens, here 2 beta hydrogens are available. In all such cases, the more highly substituted alkene, because in this case this is methyl and this is ethyl, so this is more highly substituted alkene, or sometimes is called as a lesser number of hydrogen on beta, because in this case beta hydrogen, number of beta hydrogens are 3, in this case 2. So in all such cases, the more highly substituted alkene, or having a lesser number of hydrogen atoms on double bonded carbon atom, is the major product. So this product is major in nature. So but2ene, 81% product, it's a more stable in nature. This generalization which can be given by a Satzev rule, because Satzev was discovered by a Russian chemist. His name was Alexander Zaitsev in 1875. So this generalization is known as a Satzev rule, because these explanations which can be explained with the help of Satzev rule, and this mode of elimination is called as an Satzev elimination 2, or sometimes called as an Satzev elimination 2, right? So what is Satzev rule? So according to your knowledge about the Satzev rule, right? So we know that because if we move from a bromine, right, from this beta carbon, so definitely there is a carbocation, it's a secondary carbocation. So this secondary carbocation, so how many hydrogen on these conditions and these conditions, so they form a unsaturation between alpha and beta. Now what is the cis trans isomerism? Because there is a one more important topic if we studied about the cis trans isomerism of a Satzev products. Same example, if we take a same example, 2-bromobutane. So if the substituted alkene forms during Satzev elimination is capable of showing cis trans isomerism, so the trans alkene is being more stable, is always formed as a major product. That we all know that trans is more stable. So in this case, bromine connecting carbon is alpha, here beta. So one minor product is but1ene, 19%, that we have to already observed in our prior portion. This is 19% product, right? This is 19% product. Okay. Same way, in this case is 81% product, but out of this 81, trans 2-butene having a 71% contribution, and cis 2-butene having a 19% contribution. So this is about the cis trans isomerism. Now what is the ease of dehydrohalogenation? So how the reactions of dehydrohalogenations, or the in the light of this Satzev rule, any alkyl halide, okay, that gives a more stable, means more highly substituted alkene must undergo dehydrohalogenation faster than one which give a less stable alkene. It means that if your alkene is more and more substituted, so they favor this type of the reactions. For example, I have a CH3CH2Cl, right? So it's the name of this compound is chloroethane, and it's a primary in nature. How many beta hydrogen? 3 beta hydrogen. Okay, so removal of chlorine, removal of hydrogen, so there is a alpha unsaturation between alpha beta gives ethene, but this ethene is least easily formed. Okay, but in the case of this 2-chloropropane, because it's a secondary in nature, When it reacts with alcoholic KOH, some temperature is required. So there is a removal of chlorine from alpha, and there are two positions, but both positions are identical in nature. So gives only one product, CH3CH double bond CH2 propene. But compared to this chloroethane and 2-chloropropane, the rate of the reaction is faster as compared to because here they form a secondary carbocation. In other means they having a 6 different hydrogen, beta hydrogen. If number of beta hydrogens are higher in nature, it means that they favors the reactions. Okay. Same way in the case of CH3C, CH3, CH3Cl. The name is a tertiary. Its name is 2-chloro-2-methyl propane. When it reacts with KOH in presence of alcohol, okay. So at that time, there is a removal of chlorine from alpha, and because all methyl are identical in nature, but mind well, there are 9 beta hydrogen. So more number of beta hydrogen, it means that they favor to the product is called as 2-methyl propane is most easily formed. So from this above discussion, we definitely suggest that the ease of dehydrogenation of these three alkyl halides increase as the number of beta hydrogen increase. In this case 9 beta hydrogen, in this case 6 beta hydrogen, in this case 3 beta hydrogen. Okay, in general the ease of dehydrogenations of these different alkyl halides having the same halogen decrease in the order of tertiary, because it's a tertiary in nature, secondary in nature, and primary in nature. Halogen are same, okay, but for the same alkyl group but having a different halogen, so it decreases like that, Ri, Rbr, Rcl and Rfi, because the size of iodine is quite bigger, so it's easily escape, okay, it's easily removed in the case of elimination. So elimination's energy energy required to break this iodine as compared to the bromine and chlorine and fluorine, so less amount of energy is required, so the rate of reaction is quite faster. So this is the ease of dehydrohalogenation topic. So this is all about the eliminations concept regarding to our NCERT textbook. Now what is our point number 2 is a main important point, and this important point that we have to discuss in this manner. Okay, so eliminations and substitutions. So there is a difference, there is a comparison between elimination and substitution. So why this concept is required? Because most of the examinations or entrance examinations like JEE or NEET mostly ask the question from this section, because this section is not that much deeply expressed in our textbook. So today we give some more example with the help of to clear the concept about the eliminations versus substitutions. Why this concept is required? First one, when in alkyl halide, because we know that our alkyl halide, if having a beta hydrogen, right, so it's treated with a base or a nucleophile. There's a difference between base and nucleophile. Okay, the meaning of base means they're having a lone pair, same way they're having a lone pair, but the what is the difference between this base and nucleophile? Base always connected with an acid, like acidic proton H+, while nucleophile attack towards the partially positive carbon. So that's a very good difference. So in detail, in the case of JEE Advanced, the questions which can be asked, what is the basicity and nucleophilicity, and what's the difference between this basicity and nucleophilicity, right? Fine. So in the case when alkyl halide having a beta hydrogen treated with a base or a nucleophile, so it can undergo two type of reactions: substitutions reactions like SN1 and SN2, and elimination reaction. But which reaction will occur predominantly will depend upon the following factors. The first factor is the nature of the alkyl halide. As we know that the nature of alkyl halide plays a vital role. If your alkyl halide is tertiary in nature or secondary in nature or primary in nature, if tertiary in nature and you have a very good strong nucleophile or base, it means that they favors to the eliminations reactions, right? If the nature of the alkyl halide is primary in nature, so definitely they predominantly towards to the substitutions reactions and mainly SN2 type of reactions. So it's a nature of the alkyl halide. Mind well, if we want to perform the eliminations reactions in the case of primary halide, SN2 reactions and SN1 reactions, or in the case of tertiary, how we particularly distinguish this tertiary alkyl halide undergoes elimination reactions or substitutions reaction is a simple concept. Both are tertiary in nature, but this tertiary, when reacts with a aqueous nucleophile, because aqueous is required for a SN1 reaction, because in the case of SN1 reactions you have to break the CX bond with the help of this solvent. But while in this case of eliminations, definitely we do not require any type of this water molecules, so most of the reactions which can be carried out in presence of ethanol. So nature of the alkyl halide plays a vital role to decide either the reaction is eliminations or substitutions. Same way, number 2 is the strength and size. But firstly we have to focus on size, then we focus on the strength of the base and nucleophile. Okay, so in your book, how they discuss. Okay, so I can explain with the help of here your compound is CH3 CH3Br. It's a 2 bromo propane. This 2 bromo propane, same way here the 2 bromo propane. So we know that this isopropyl bromide is secondary in nature. Now our attanging material is CH3CCH, so it's a tertiary butyl oxide or tertiary butoxide, and it's a hydroxide. So what is in this case of tertiary butyl ioxide? They are bulky in nature. They are crowding in nature. So it's difficult to approach this partially positive carbon. So they prefer to accept the proton from this haloalkane. So they favor to the eliminations reaction. So it's hard for them, right? While in this case of isopropyl bromide, when reacts with OH minus, so OH minus is not that much bulky. It's a smaller molecule. So definitely they approach or they attack or they back attack towards to the partially positive carbon. So they favor to the substitutions reactions. It means that once again, due to steric reasons, a bulkier nucleophile will prefer to act as a base because they accept proton from this haloalkane and abstract a proton to give the elimination production rather than attanging a tetrahydrocarbon to form a substitution product. So the secondary alkyl halide may undergoes a substitution reactions by SN2 mechanism or eliminations depending upon the size of base or nucleophile. So this is the first concept about the nature of the or size of the base or nucleophile. Now we focus on strength. What is the strength that relate with the rate of the reaction? Same example. It's a 2 bromopropane. It's a 2 bromopropane. When this 2 bromopropane is react with a 2 different types of base. This CH3COO minus Na plus, and this is CH3CH2O minus Na plus. Because oxygen and oxygen in this both case, they act as because they have a lone pair, so they act as a Lewis base, right? But which base is act as a base and which base is act as a nucleophile? So which is depends upon because this is a weak base and this is a strong base. If weak base, so definitely they connect with the because there is the power of weak base is do not attach with the beta hydrogen. That's why we get two different products, CH3CH3O, because CH3CH3O COCH3, right? So this is a product of substitutions. If the eliminations reaction, so it's a propene, but 0% practically 0% of propene and 100% of this substituted product that we have to form. So it means that weak base definitely favors to the substitutions reaction. But if we perform the reaction with a strong base like CH3CH2O minus Na plus is a very good strong base. So this strong base definitely they approach to the beta hydrogen and abstract a proton to give the eliminations production rather than attacking the tetrahedral carbon. So we get two different products same way, CH3, CH3, OCH2, CH3 20% and CH3, CH double bond CH2 is 80%. So I think so you have a certain idea what is the nature of alkyl halide, then the strength and size of the nucleophile. Third condition is the reactions condition. So reactions conditions in this case is a harsh reactions conditions is required for elimination reactions. Why? Because one more example, this is primary alkyl halide, right? We know that primary alkyl halide prefer to undergo substitutions reactions by SN2 mechanism. For example, this ethyl bromide, when treated with either aqueous NaOH or aqueous, mind well it's aqueous, not alcoholic in nature, right? Can with at 100 degree centigrade temperature undergo substitutions to form a ethyl alcohol, or ethanol. However, primary alkyl halides, okay, can still be made undergo eliminations by use of strong base than NaOH or KOH, so less polar solvent such as alcohol rather than water and high temperature. Thus ethyl bromide when heated with ethanolic KOH, because they form a C2H5O minus ion. Okay, C2H5O minus is a very stronger base than hydroxide ion. So C2H5OH is also less polar than water. So and we perform the reaction at 200 to 250 degrees centigrade temperature. So they favor to the eliminations reactions. So in general, eliminations reactions required. Why high temperature is required? Because in substitutions reactions, because here in this case we have to break alpha. There is a bond between CBr. We have to break this bond and hydrogen CH bond. So we have to due to the cleavage of larger number of bonds. So the energy of activation of elimination required is higher, because in the substitutions reaction in which we have to break only one bond. So that's why high temperature is required. So for example, in the competitive examinations, they ask the question in such a manner that so at that time you have to focus on what conditions they given. They given a high temperature and alcohol. If they so it means that they predominantly favors to the eliminations reactions. Same way, tertiary alkyl halide. This is tertiary alkyl halides. They preferentially undergo eliminations reactions. For example, if I having a tertiary butyl bromide, right, on heating with ethoxide ion, this is ethoxide ion, we know that it's a very good strong nucleophile, right? So in ethanol mainly undergoes to the eliminations reaction. We got the 97% of eliminations reactions compared to the substitutions reactions. But if however tertiary butyl bromide is heated with a very nucleophile such as only pure ethanol, so both products substitutions and eliminations occur, but in which substitutions is predominant. Why? Because in this type of the reactions where your ethanol is a solvent, but its solvent is act as a nucleophile too, so this process is called as a solvices, and this solvices of tertiary alkyl halide occurs by SN1 mechanism. So this is all about the eliminations and substitutions, but we have to focus on these three conditions. Nature of alkyl halide, tertiary, so it's a very good chances for eliminations. If strength is quite good, so very good chances for elimination. Size is bulkier, then they favor the eliminations reactions. In harsh conditions like a high temperature is required, so definitely they favors to the eliminations reactions. So when we have to in such a puzzle type of questions, so which reactions can perform eliminations substitutions, at that time we have to focus on these three different parameters. So up to now we completed this eliminations topic. In next lecture we start with reactions with metals and some problems related with these eliminations reactions. Thank you very much.